audio, blue smoke, semiconductor physics. So last time we saw solar cell, how electrical energy can be generated using semiconductor cell, P junction, N junction, and potential is developed across it. Now the last diode, यानी कि हमने इतनी तरह के डायोड देखे, पहले पीएन जंक्शन डायोड, फिर उसका रेक्टिफायर करके यूज कैसे होता है, हाफ वेव रेक्टिफायर, फुल वेव रेक्टिफायर. Then we saw the working of Zener diode characteristics. Zener diode as voltage regulator. Then we learned about photodiode, and in that photoelectric effect also we saw similar device. After photodiode we saw the solar cell. Now the last diode is light emitting diode or LED. LED is a diode which emits light when large forward current passes through it. So it is exactly opposite of photodiode. Photodiode मध्ये काय होतं कि when light is incident on it, it starts conducting. Here, when it is conducting, it emits light. Correct. Just opposite. This is a symbol of LED. So we'll write about it. LED. It is a diode which emits light when large forward current flows through it. LED, light emitting diode. What is the description? A diode which emits light. A diode which emits light when large forward current flows through it. That means when the diode is forward bias, it offers less resistance, and when resistance is less, the current is high, and at that time it starts emitting light. How do we show the symbol? Again, exactly opposite to that of the photodiode. Draw the symbol of a diode like this, triangular, and just show the light coming out of that diode. So this is the symbol of light emitting diode. Construction of LED is different than that of the normal diode. N region is heavily doped than the P region, and PN junction is encased in a domed shape, transparent case, so that light is emitted uniformly in all directions and internal reflections are minimized. So this is a PN junction diode in which N region is heavily doped the N region, is heavily doped than the P region. N region is heavily doped than P region. PN junction is encased in a dome-shaped transparent case. PN junction is encased in dome-shaped transparent case. So that light can come out of that. Larger leg is positive terminal, shorter is negative. This is just a convention for the connection of LED. Larger leg is positive, obviously shorter is negative, लिहायची गरज नाही. LED is fabricated in such a way that light is emitted and not reabsorbed into the material. Electron-hole recombination takes place at the surface for the maximum light output. So then the working of LED, how does the LED work? LED काम कैसे करता है? Let us see. So figure 16.16 here, it gives the working of LED. When the diode is forward biased, that means when the positive terminal of the battery is connected to the P type and the negative terminal connected to the N type, that is, it is when forward biased, electrons from the semiconductor's conduction band recombine with holes from the valence band, releasing sufficient energy to produce photons which emit a monochromatic single color light. And because of thin layer, reasonable number of photon can leave the junction and emit the colored light. Amount of light output is directly proportional to the forward current. Higher the forward current, higher is the light output. LEDs are fabricated by using compound semiconductors such as gallium, phosphorus, arsenic. By varying the proportions of these elements in semiconducting materials, it is possible to produce lights of different wavelength. अलग अलग रंग का मतलब क्या? अलग अलग वेवलेंथ. और अलग अलग वेवलेंथ कैसे आती है? फोटोन के अलग अलग फ्रीक्वेंसी से. नाउ यू मस्ट बी अंडरस्टैंडिंग दिस कि द एनर्जी ऑफ फोटोन इज इक्वल टू एच न्यू और इक्वल टू एच सी अपॉन लैम्डा. तो द कलर इट डिपेंड्स ऑन which photon is emitting, and that depends on the material. Like aluminium, gallium arsenide, it emits infrared radiation. Gallium arsenic phosphide, red or yellow light. LED using aluminium gallium phosphide, it emits red or green light, or zinc selenide, it produces blue light. VI characteristics are same as that of any other PN junction diode. So VI characteristics are not different. So let us write these things about LED, light emitting diode. We'll write the working of LED. Working is also very similar to PN junction diode, that electrons and holes recombination take place, and due to this recombination energy is released in the form of photons, and that is the speciality of this diode. So working, when diode is forward bias or when LED is forward bias, biased, electrons from the conduction band recombine with holes in the valence band, and this recombination produces energy in the form of photon. Recombination of electrons and holes results in emission of photons amount of light is directly proportional to the forward current, means intensity of light or amount of light is directly proportional to forward current. More the forward current, more is the amount of light. Aluminium gallium arsenide it emits infrared, then gallium arsenide phosphide emits red or yellow, then aluminium gallium phosphide emits red or green, and finally zinc selenide emits blue light. So like this, VI characteristics are very much similar to any other PN junction diode. So just if you can draw them in a corner, initially the current changes slowly, afterwards it changes fast. So like this इट इज देअर. असं इथे काय सरळच जाईल ते. लाईक दिस इट गोज. So 1 2 3 4 5 volt like this you can write. 0 1 2 3 4, these are the volts, and current is in milliampere, like 10 20 30 40 milliampere. So these are the VI characteristic of diode. What are advantages of LED? Energy efficient, more LED output for lesser electrical power. और ये हम अभी देख रहे हैं ना कि हमारे सारे घर की जो लाइटिंग है वो आजकल ये LED की बन चुकी है, एंड दिस इज बिकॉज ऑफ द इफिशियंसी ऑफ LED. दैट मीन्स पहले जो 60 वैट का बल्ब हमें लगता था टंगस्टन फिलामेंट वाला, उसके बदले हम 8 या 9 वैट का LED इस्तेमाल करके हमें उतना ही लाइट मिलता है. सो एनर्जी इफिशियंसी इज अ वेरी इंपॉर्टेंट फैक्टर. हाई अमाउंट ऑफ लाइट, देन लॉन्ग लाइफ टाइम, 50,000 hours, long lifetime. Another advantage, they are solid state lights, so they are rugged. That means मराठी मध्ये याचा अर्थ दणकट. Then no warm up, that means they do not get hot. जसं की आपले इनकॅन्डिसंट लाईट गरम व्हायचे आणि त्याच्यामध्ये एनर्जी खर्च व्हायची त्यांचा हीटिंगमध्ये, तर हे लाईट LED लाईट आहेत ते गरम होत नाहीत. एक्सलंट कलर रेंडरिंग, इको एन्वायरमेंट फ्रेंडली. Excellent color rendering, that means different colors are available. Eco-friendly, environment friendly. Then they are controllable. The brightness and color of the light can be easily controlled using electronic devices. So controllable. So these are the advantages of LED. Disadvantages are hazardous blue light quality, temperature dependence, voltage sensitivity, and high initial cost. So where this LED lighting is used? LED कहाँ पे इस्तेमाल होता है? They are used in variety of ways, like burglar alarm systems, counters, optical communications. Optical communications means जो ऑप्टिकल फाइबर होते हैं उनमें, इंडिकेटर लैम्प्स इन इलेक्ट्रिकल इक्विपमेंट, डिजिटल स्क्रीन, LED टेलीविजन, व्हीकल हेडलैम्प, डोमेस्टिक एंड डेकोरेटिव इल्यूमिनेशन, स्ट्रीट लाइट्स. दे आर यूज्ड इन 7 सेगमेंट डिस्प्ले. 7 सेगमेंट डिस्प्ले क्या है कि जिसमें 7, आजकल तो इतना यूज नहीं होता, पहले जब डिस्प्ले की कीमतें ज़्यादा हुआ करती थी तो आजकल भी कहीं कहीं यूज होते हैं, लाइक ऑन इलेक्ट्रॉनिक डिवाइसेस. तो ये 7 सेगमेंट डिस्प्ले की स्पेशलिटी ये थी कि उसमें से अलग अलग लाइट मीन्स ग्लो करके हम सारे डिजिट्स ला सकते थे, और फिर कुछ अल्फ़ाबेट्स भी उनमें से हम ला सकते थे. तो ABCDEFG ऐसे करके 7 LED है वहाँ पे, और उनमें से मीन्स लाइट करके हम सारे नंबर डिस्प्ले कर सकते हैं। तो ये हो गए हमारे डायोड्स। तो डायोड का जो सेक्शन था वो यहाँ पे खत्म होता है। और फिर आगे है ट्रांजिस्टर। डायोड हैज ओनली 2 आर्म्स, पी जंक्शन एन जंक्शन, लेकिन ट्रांजिस्टर को 3 आर्म्स होते हैं। A junction transistor is a semiconductor device having 2 junctions and 3 terminals. उसमें 2 जंक्शन है और 3 टर्मिनल यानी आर्म बोला वो। The current in a transistor is carried by both the electrons and the holes. Hence it is called a bipolar junction transistor or BJT. A transistor has 3 doped regions from a structure. They form a structure of 2 back-to-back PN junction. So there are 2 types of transistor. One is NPN junction, यानी उसमें P type जो होता है semiconductor, that is at the center, and we have a PNP transistor, a circuit symbol and schematic representation. ये पुराने बुक में ये गलत दिया है उसका, तो अगर तुम्हारे बुक में गलत दिया है तो सुधार लो। NPN और PNP ट्रांजिस्टर सिंबल्स आर लाइक दिस, आई विल शो यू। इस तरह से सिंबल है, कलेक्टर बेस इमिटर, PNP एंड NPN। like this they are there. In old textbook they have shown in opposite way, यानी PNP को NPN बताया और NPN को PNP बताया। तो हमेशा याद रखो कि NPN में एरो इज आउटसाइड एंड PNP में इट इज इनसाइड। ये एरो आउटसाइड always represents NPN transistor and arrow inside it represents PNP transistor. So if in your textbook it is shown in a wrong way, just change their names. In the circuit symbol, emitter and collector are differentiated by drawing an arrow. Emitter has an arrow either pointing inwards or pointing outwards. Direction of the arrow indicate the direction of the conventional current in the transistor. For a NPN transistor, arrow it points away from the emitter. So जो text में दिया है वो correct है. In NPN transistor, arrow points away from the emitter, and for the PNP transistor, it points from the base towards the emitter. This is shown. In an NPN transistor, P-type semiconductor, that is base, separates the 2 layers of N-type, and in a PNP type, N-type is in between and P-type is. So we have 3 different regions. A transistor can be thought of 2 PN junctions. They are connected back to back. तो ये तीन रीजन कौन से हैं? लेट अस राइट देम। तो फर्स्ट हेडिंग क्या लिखेंगे, वो सिंबल्स तुम ड्रॉ करो। बाइपोलर जंक्शन ट्रांजिस्टर BJT, बाइपोलर जंक्शन ट्रांजिस्टर। Bipolar junction transistor BJT. One is emitter. Emitter is thick heavily doped layer. 3 जो उसके रीजन है उसमें पहला रीजन है emitter, and emitter is heavily doped region. Heavily doped means impurity concentration is high. This supplies large number of majority carrier for the current flow. This provides large number of majority carriers for conduction. तो NPN ट्रांजिस्टर में इमीटर N टाइप का होता है और PNP ट्रांजिस्टर में इमीटर P टाइप का होता है. Then base is a thin, lightly doped control region. दूसरा है base. Base it is a lightly doped thin control region. And collector, it is on the other side of the base. It is thick and moderately doped region. तीसरा है collector, and collector is thick and moderately doped region. It is a thick and moderately doped region. Its area is larger than emitter, and this layer it collects major portion of majority carrier, so its area is highest. Area is larger than emitter, and it collects a major portion of majority carriers, and it collects the major portion of majority carriers. So as the name suggests, it collects the charges. Depletion region. The depletion region are formed at the emitter base junction and the collector base junction. Emitter current is shown by letter IE, base current IB, and collector current IC. So apart from this collector base emitter, there are depletion regions which are formed between emitter base and collector base. Depletion region means the regions where the carriers are not present. Depletion region. Depletion regions, emitter base junction and base collector junction. Emitter base junction and collector base junction. Then the currents that are flowing IE is emitter current, IB is base current, and IC is collector current. Emitter base junction has low resistance while base collector junction has high resistance. Emitter base junction, EB junction, has low resistance whereas base collector junction has high resistance. There are two PN junctions, one is emitter base and one is collector base. They can be biased in different ways. The most common method of biasing a transistor, emitter base is forward bias and collector base is reverse bias. The emitter base is generally forward bias and collector base is generally reversed bias. This helps in easy flow of majority carrier supplied by the emitter through the transistor. Then we see the working of a transistor, how a transistor works. Electrons are the majority carriers in an NPN transistor. Emitter current IE is due to electrons. Current flows through the emitter base junction and it is large because emitter base junction is forward bias. You can see here this negative terminal of the battery connected to the N region, positive to the P region. So this emitter base junction is forward biased. Base collector junction is reversed bias. It is interesting to know how this is possible. Figure 16.19a shows typical biasing of an NPN transistor. At the instant the forward bias is applied to the EB junction, electrons in the emitter region, that is N-type, have not entered the base region as shown in the figure. So you can see that here the electrons are there. Majority of electrons are injected by the emitter into the base and are thus collected by the collector and flow through the collector circuit. A PNP transistor works exactly same, but in that case the majority carriers are holes. So when a biasing voltage VBE is greater than the barrier potential in silicon transistor which are used, many electrons enter the base region from the emitter region as shown in the figure. These electrons can now flow into two directions. They can either flow through the base circuit and constitute the base current, and they can also flow through the collector circuit and contribute towards the collector current. Base current is very small, 5%, because the base is very thin and also it is lightly doped. Base of a transistor plays a crucial role in its action. Electrons injected from the emitter into the base diffuse the collector region. म्हणजे तो बेस एवढा थिन असतो, वो बेस इतना थिन होता है कि वो उस बेस रीजन से बाहर जाने वाले इलेक्ट्रॉन की संख्या बहुत कम होती है. 100 में से 5 सिर्फ वो बेस करंट कॉन्स्टिट्यूट करते हैं. बाकी के सारे इलेक्ट्रॉन्स ये कलेक्टर रीजन में जाते हैं और कलेक्टर रिवर्स बायस होने के बावजूद भी उसमें जब इलेक्ट्रॉन चले आते हैं तो all are attracted towards this positive terminal of that collector based battery. So collector current is also very high. So in all we can write the equation. कुल मिला के हम ऐसा इक्वेशन लिख सकते हैं कि IE is the total current and that is nothing but addition of IC and IB. तो अगर IE तुम्हारा 100% है तो IC उसमें से 95% होता है और IB सिर्फ 5% होता है, एंड दैट इज बिकॉज ऑफ दैट स्पेसिफिक डोपिंग एंड द थिकनेस, डोपिंग और थिकनेस की वजह से. So you can draw this diagram to show how the electrons are transferred. The electrons are transferred like this. A PNP transistor you just replace electron with holes and then you will see that. So ये हो गया transistor का working. Tomorrow we will see the input output characters of transistors and logic gates. So we will stop here today. Tomorrow we will continue. Okay.